Difference curves are all about trade-offs. How much of one good a consumer will give up to get a little bit more of another good. If Sarah is deciding between socks and t-shirts, then this trade-off will tell us how many t-shirts she would be willing to give up to obtain extra pairs of socks. We know that the slope of the indifference curve captures this trade-off, and we want to explore this in more detail. First, how can we precisely measure the slope of an indifference curve at a particular point? For instance, point A. It turns out we can use the slope of a line that touches the curve at that point, does not pass through it, and does not touch any other point. This line is called the tangent line. To see why the slope of the tangent line is used to measure the slope of the indifference curve, let's examine the region around point A in more detail. In particular, notice that for a region very close to A, the tangent line mimics the curve almost perfectly. Thus, for small changes, the rate of change of the curve will equal the rate of change of the tangent line. This means that we can use the slope of the tangent line to tell us the precise trade-off a consumer would be willing to make between goods. Applying this to our indifference curve at point A, this is the tangent line touching Sarah's indifference curve. The slope of this tangent line will equal the slope of Sarah's indifference curve at point A and will tell us her willingness to trade t-shirts for pairs of socks. To calculate the slope of the tangent line, we calculate the rise over the run. The rise is -1 t-shirt, which we can read directly off the t-shirt axis. The run is 0.5 pairs of socks, which we can read off the socks axis. The slope of the tangent line is then -1 over 0.5, or -2. Thus, we know that Sarah would be willing to trade 2 t-shirts to receive 1 more pair of socks at point A. We can use the same technique to find Sarah's trade-off between t-shirts and socks at any point on her indifference curve. For instance, if we want to find her trade-off at point B, we first find the tangent line. We can then determine her trade-off between t-shirts and socks by finding the slope of this line. First, we'll find the rise of her tangent line, which is -0.5. Then we'll find the run, which is 1. The slope of this tangent line is then -0.5 over 1, or -0.5. Thus, we know that Sarah would be willing to trade a half of a t-shirt for 1 pair of socks at point B. This concept of the trade-off between the goods is so important that economists have given it a particular name, the marginal rate of substitution of X for Y, or MRS of X for Y. The term marginal just means that we are focused on small changes in the bundles of goods. For these small changes, the MRS of X for Y is the rate at which we would be willing to substitute the good on the horizontal axis for the good on the vertical axis. Intuitively, it is the relative value that a consumer places on obtaining a little more of the good on the x-axis in terms of the good on the y-axis. Mathematically, the MRS of X for Y equals the negative of the change in the good on the y-axis divided by the change in the good on the x-axis that makes the consumer just as well off. Note the change in the good on the y-axis divided by the change in the good on the x-axis is just the rise of the indifference curve over the run. In other words, it's just the slope of the indifference curve. Thus, MRS of X for Y is the negative of the slope of the indifference curve at a particular point. The reason we include the negative sign is just to make the marginal rate of substitution a positive value. For instance, we would have to give up the good on the y-axis to get more of the good on the x-axis.